Welcome back, guys, and I do hope you and your family are keeping well. So, welcome to your next lesson on energy, and the energy we're going to look at today is kinetic energy. Okay, so I hope you all know that kinetic energy is the energy of movement, the energy of motion. So, my space shuttle toy sitting here has not got any kinetic energy. It's not moving. It has got gravitational potential because it's not down on the floor. Okay, but we're not going to worry about gravitational potential. That was your last lesson. We're going to look solely today at kinetic energy. Okay, so to give something kinetic energy, you've got to get it moving. Yeah, I don't know if this one works anymore, but reasonably unimpressive. But you've got to make sure that it has some movement. Okay, so I'll switch over from the space shuttle model. Bit of fun this actually. My memory is I actually bought this when I went to see a real launch. So I actually went to Florida. I was learning to fly float planes many years ago, and they actually launched a shuttle in the night. A friend of mine actually was an astronaut, but she wasn't on that mission. Friend acquaintance, but yeah, I think I bought that at NASA then. So brings back some memories. Okay, here we go. Now, physics dudes in classrooms always use these sort of trolleys. Be aware that in your exam, it could be a car, it could be someone running, it could be anything. Okay. Now, I think it's pretty obvious that I make this speed up. So I do work on it. And if I do a little bit of work, it goes quite slowly, slows down because of friction. And if I do a lot of work, it goes faster. Okay. So, give it a small amount of energy and it goes slowly. Give it a large amount of energy and it goes fast. Okay, so what we need to do today is to say, okay, we know that kinetic energy is the energy of movement, but how can we calculate it? And you're in for a bit of a shock. It's not an easy formula. Okay, it's much harder than gravitational potential energy, but you'll get your heads around it, and it scores high marks at GCSE. So, what does kinetic energy depend upon? Well, it's actually, in some ways, quite easy. Isn't it obvious that if it goes slowly, it has a small amount of kinetic energy, and if it goes quickly, it has a large amount of kinetic energy. So, kinetic energy depends upon velocity, okay, speed, yeah, velocity. Okay, remember separately, velocity is a vector quantity, so velocity is a speed in a fixed direction. So this one's slow or medium kinetic energy, that's a high kinetic energy, and that's a low kinetic energy. But hang on, what happens if I make this a bit heavier? Okay, now this is an interesting thing because I'm not going to lift it up. So we're not talking about gravitational potential energy. But if I make it heavier, okay, I'll show you how cleverly in a minute. But if I push it, it's got kinetic energy. And if I push it harder, it's got more kinetic energy. Okay, so that all agrees with what we've done before. But think about what would happen, poor old Bjork here gets hit all the time, if he was hit by a low kinetic energy, high mass thing, and a high kinetic energy, high mass trolley. Okay, so I hope you gave that some thought. The difference between being hit by the trolley that was going along with a low mass and the trolley that was going along with a high mass. Well, I've had to push this one harder because it's heavier, so it's got more kinetic energy. He would have a worse collision. Okay, and there's a little bit of momentum physics in there, but that's not for now. So, how do we explain that? Well, if you think about it, okay, I have to speed up these atoms. Shall we say there's 1 kilogram of them? I have to speed up 1 kilogram of atoms and get it up to speed. But if I put this on as well, shall we say that that's 1 kilogram? Okay, it's actually, it says on it, it's 2 kilograms. Okay, so this is now 3 times heavier, 1 and 2, 3 kilograms. I'm going to have to speed up the atoms in the trolley and these atoms to get them to the same speed as before. So I'm going to have to put energy into this and these 2 kilograms. So I'm going to have to put in, overall, more energy. So what we're noticing here is that kinetic energy seems to depend upon the mass of something, okay? And we measure the mass in kilograms. So slow things have low kinetic energy, low velocity, okay? High velocity have high kinetic energy. Heavy things will have more kinetic energy than light things going at the same speed. And that's all we can change. So, kinetic energy depends upon two things. How fast you're going, your velocity in meters per second, and it depends upon your mass, how many kilograms of material. So, we need a formula, and it's not just as simple as multiplying those two together. Okay, so in a minute I'll go up to the board and I'll show you the formula we use to calculate kinetic energy. It's a tricky one, but remember, if you get your head around it, this is the one that will get you high marks at GCSE. So let's now look at kinetic energy, okay, or kinetic energy if you so wish. This is the energy of movement, if you remember, and we call it KE. Now, of course, at GCSE, again, we're a bit more advanced, and we will write it as energy with a little K down there to remind us that that number is kinetic energy. So it's the energy of movement. So, in some ways it's an easy one, this, but the maths is a little bit more tricky. So we'll keep it dead simple. If I draw that little trolley moving along, and I said that it goes forwards with a velocity, if we make that velocity faster and faster and faster, it's got more kinetic energy. But the other thing we did was we loaded it up. I put a weight on top of it. Okay, and now the trolley is the mass of the its weight's not a good term, but you know what I mean. Its mass is that of the mass on top and the trolley itself. Okay, so it's the whole thing has a mass. Okay, if it is moving at a speed, but it's now got more mass, it's got more kinetic energy because we had to speed up the trolley and the mass on top. Okay. Now, do remember, of course, what we measure these in. We will always measure velocity in meters per second, and we will always measure mass in kilograms. Okay? So, if we increase the speed, the velocity, it's got more kinetic energy. If something is heavier going at the same speed, then it's got more kinetic energy. So, think quickly of a car going at 60 miles an hour. And think of a bus going at 60 miles an hour. The bus has had to use more fuel to get up to speed, and it's got more kinetic energy, not because it's going faster, but because it has more mass. It's had to speed up more atoms. So let's now look at the formula for kinetic energy, and it's not an easy one. The kinetic energy, okay, so that's just E, but with a little K to remind us which one it is calculated by doing a half the mass, okay, a half the mass times by the velocity squared. Okay, now if you're good at maths, you know, you don't need to listen to me here, but if you struggle a little bit, look at what that says. V squared. V squared is one number. I'm not going to put brackets around it, but if you do a calculation at GCSE, you must do the V squared as one thing. Do it first and then multiply by half the mass. Okay, so let's very quickly put some numbers in. So let's make the whole of this thing, yeah, this trolley system here, let's make that 10 kilograms. Okay, and let's have it going at, shall we say, 2 meters per second. So that's its velocity. Okay, so we'll stick the numbers into the equation. So the kinetic energy of this moving object will be a half times by the mass, which is 10, times by the velocity, 2 squared. Okay, so the kinetic energy of this trolley will be half times 10, which is 5, times 2 squared, which is 4. So the kinetic energy of this trolley will be 5 4s are 20. And again, I always throw my hands in the air when teaching these things and saying, what have we done wrong? The energy is measured in joules. So it's quite a difficult formula, this one, okay? But the energy stored in a moving object is a half mv squared. Now, be warned that if you want really high marks in an exam, you might have to rearrange this and you might have to get v out of the equation. But at the moment, this will do, okay? So you've now got a good understanding of the formula to calculate kinetic energy of a moving mass.